Welcome to an example of numerical integration. We want to use Simpson's rule with n equals 6 to approximate the given definite integral. The formula for Simpson's rule is given here below, and there are several things to recognize here. First, notice a is the lower limit of integration, and b is the upper limit of integration. So for this example, a equals 1 and b equals 6. We're also told that n equals 6, so we'll have n subintervals on the interval from 1 to 6. So now let's determine delta x, which will give us the width of each subinterval. Delta x is equal to b minus a divided by n, or 6 minus 1 divided by 6, which is 5, 6. So delta x equals 5, 6. So x sub 0 would be equal to 1, the lower limit of integration. X sub 1 would be 1 plus delta x, or 1 plus 5, 6, that's 11, 6. Next would be x sub 2, which would be 11, 6 plus 5, 6, that's 16, 6, or 8 thirds. X sub 3 would be 8 thirds plus 5, 6, which would be 21, 6, or 7 halves. Next, x sub 4 would be 7 halves plus 5, 6, which would be 13 thirds. X sub 5 is equal to 13 thirds plus 5, 6, which is 31, 6. If we do this correctly, x sub 6 should be the upper limit of integration. So then 31, 6 plus 5, 6 is 36, 6, or 6. Now before we set this up though, remember when using Simpson's rule, we're actually using quadratic functions to make our estimate. And we form quadratic functions over two subintervals, which is the reason why when using Simpson's rule, n must be even. So let's take a look at the graph of our function over these subintervals before we use our formula. So here's the interval from 1 to 6 divided up into our subintervals, x sub 0 through x sub 6. These green points would be the points that we would use to form the quadratic functions to make our estimate. So the first quadratic function, we would use the first 3 green points over the first 2 subintervals. So the first quadratic might look something like this. The second quadratic would be over the interval from x sub 2 to x sub 4, maybe something like this. And then the third quadratic would be over the subinterval from x sub 4 to x sub 6, that might look something like this. So because of the way this function curves, you can see how quadratic functions would be a good estimate for this definite integral. And now let's set up our formula. The definite integral is going to be approximately equal to b minus a divided by 3n. That's going to be 6 minus 1 divided by 3 times 6 times, notice here we have f of x sub 0, then we have the coefficients 4, 2, 4, 2, 4, and then we'll have f of x sub n, or in our case, f of x sub 6. So we begin with f of x sub 0, or f of 1, plus 4 times f of x sub 1, that's 4 times f of 11, 6, plus 2 times f of x sub 2, or f of 8 thirds, plus 4 times f of x sub 3, or f of 7 halves, plus 2 times f of x sub 4, or f of 13 thirds, plus 4 times f of x sub 5, which is f of 31, 6. And then we end with just f of x sub 6, so f of 6. Let's begin simplifying this. This would be 5/18 times, we'd have cosine 1 divided by 1 plus 4 times cosine 11, 6 divided by 11, 6 plus 2 times cosine 8 thirds divided by 8 thirds plus 4 times cosine 7 halves divided by 7 halves plus, where are we here, 2 times cosine 13 thirds divided by 13 thirds, and we're almost there, plus 4 times, we'd have cosine 31/6 divided by 31/6, and then finally plus just cosine 6 divided by 6. And now I'll show how we can use the calculator to approximate these function values. First thing we should do is make sure we're in radian mode, so we'll press the mode key. Notice that radian is highlighted. If it wasn't, we would highlight radian and then press enter. And then from the home screen, what we're going to do is type in our function cosine x divided by x into y sub 1. So we'll press y equals, clear out any old functions, and type in cosine x divided by x. Go back to the home screen, press second mode, and then for cosine 1 divided by 1, that's just going to be y sub 1 of 1. So we'll press vars right arrow, enter, enter, and then instead of f of 1, we'll enter y sub 1 of 1. So in parentheses, we enter 1, it'll give us the function value. So to 4 decimal places, this would be approximately 0.5403. For this next product, this is 4 times f of 11/6. We'll type in 4 times y sub 1 of 11/6. So 4 times vars right arrow, enter, enter, and then in parentheses 11/6. This method would avoid any entering errors if we try to enter this expression in this form here. So it's approximately negative 0.5663. Plus, here this would be 2 times f of 8 thirds. So 2 vars right arrow, enter, enter, then in parentheses just 8 thirds. So this would be, to 4 decimal places, negative 0.6670. And to save some time, I've already determined the rest of these values. You'd have plus negative 1.0702 plus negative 0.1708 plus 0.3397, and finally plus 0.1600. And then 5/8 times this sum would give us approximately negative 0.3984. This would be our approximation of the definite integral using Simpson's rule when n equals 6. I hope you found this explanation helpful.